A farmer is driving a vehicle across an uneven field in which there are undulations every 3 meters. He's probably she's driving out into the field to determine why there are undulations every 3 meters, right? Okay, sorry. All right. Well, explain why it would be uncomfortable for the farmer to drive the vehicle at a speed of 5.6 meters. Well, what we're looking for here and all of these things, right, is that somehow this thing is being disturbed at its resonant frequency, right? So we're looking for 1.9 hertz, right? Okay. So how frequently will we hit these things, right? I think we can all agree that the period is going to be the period will be the distance divided by the velocity, right? So that's going to be 3 meters divided by 5.6 meters per second, right? And then the frequency will be 1 over the period, right? You could also just say, look, the frequency is going to be what? The velocity divided by that distance between the two, right? Okay. But anyway, ultimately, when you figure it out, you'll realize that the frequency is close to 1.9. So I think the first thing to do is to figure out maybe the frequency. We got 3 marks here, right? Ultimately, though, what you want to do is talk about how if this thing's being perturbed at its resonant frequency, it's going to have large amplitude oscillations, right? Outline what change would be required to the Q value of the mass spring system in order for the drive to be more comfortable. Well, decide whether you want more damping or less damping, right? I think that's obvious. And then decide what do you do to Q, right? So say you're increasing the damping, right? What's happening to the Q factor? Are you increasing or decreasing the Q factor? Okay. Anyway, I think you can answer that.